Hello and welcome to our lesson on radicals to exponential form. First, let's talk some definitions. A radical is an expression, so that's no equal sign, that includes a number, can also include a variable, a radical, sometimes called a root sign, and an index. If you remember, the radicand is the big number, the exponent is the teeny tiny number attached to the radicand, you've got your radical sign, and the teeny 2 that was there, that's your index. So, for exponential form, a radical term can be written in exponential form. This is when the numbers and the variables too become the base, the big number, and the index becomes part of the exponent. And usually it's in fraction form. So when we said base, that's the base number. And the exponent involves the original exponent and the index. Here's how it works. The radicand becomes the base. That's the big number. The index becomes the denominator. The teeny tiny one becomes a denominator right there. The exponent to the radicand, that 3, becomes the numerator, the top number. And then the radical sign disappears and changes into that division sign right there. So let's see if we did it right. Watch. The index of 2 moves to denominator. The exponent of 3 stayed as the numerator, the exponent still attached. And the radicand of 6 became the big base. So let's try it. I've got 10 is my radicand, so that stays the big base number. 4 is the exponent, and it stays attached to the 10 is the numerator. My radical sign turns into division for the exponent. And here we don't have an index, so it's assumed to be 2. So that becomes your denominator. Now you can reduce that exponent fraction. You can turn it into 10 to the 1/2. We're not going to go ahead and solve it. I just want to show you how to go from radical to exponential form. Now here you have a numerator and a denominator, so we still need to have a numerator and a denominator when we do this. They become the bases. You'll notice you don't have any exponents here, but you do. If there's not one there, it's assumed to be 1. And the original exponents stay as the numerator. My index becomes the denominator on both of the bases. So it's really 9 to the 1/3 divided by 27 to the 1/3. Like I said, we're not going to solve it, we're just going to stop there because that's how you transfer from radical to exponential. Let's take a look at just a few more examples. You've got 24.5. Doesn't matter that it's a decimal, still stays as your big base number. You've got an exponent of 5, so that is your numerator on your new fraction there. And the 5 for your index becomes the denominator here. Now you can reduce it and simplify it. What's 5 divided by 5? 1. So it's actually 24.5 to the first. And then here, again, you've got a fraction, so we're going to have to keep it as a fraction. You've got 16 over 64. Those become your base numbers. There is an exponent there and 1 there. So it's not written, it's assumed to be 1. So 1 is your numerator for both of these. No index, it's assumed to be 2 for both of them. And because the entire thing is negative, you're going to have to stick a negative sign out in front of the whole thing. And you can stop there. We'll teach you how to do the actual finishing of the problem later, but right now you understand how to go from a radical to an exponential form. Quick review. The radicand becomes the new base. That's the big number. The index, the teeny tiny number, becomes the denominator, the lower number, for the exponent that's attached to the new base. The original exponent that was attached to the radicand becomes the numerator, and the radical sign goes away and it creates that division sign. So the new base, the original exponent, the index, and the radical sign became there. And that's how you go from a radical to an exponential form. And that's it for our lesson on radicals to exponential form.